What's up? This is Mario, and welcome to Awesome Acoustics. In this episode, we will learn how to use Audacity, which is a free audio editing software. Audacity is a super useful tool to study sound and experiment. Also, in future episodes, there will be times when we can test theory with simple exercises in Audacity. So, it will be very convenient for us to know how to use this software. This tutorial is based on Audacity 3.1.3. I will leave the link to download Audacity in the description. Although, you can also easily find it on Google. This is the Audacity interface. To explore the features, we will first load a music file by going to File, Open. I will drag the track from below to make it wider. For stereo audio, that is, audio with two channels, the first wave is the left channel, and the second one is the right channel. Now, let's explore the functions. These are the play buttons, although they are much easier to use via keyboard shortcuts, especially the spacebar to play and stop. While the sound is playing, you can move forward or backward 1 second with the left and right arrows. To zoom in and out, you can use Ctrl 1 and Ctrl 3. Or you can use Ctrl and the mouse wheel. If you get close enough, you will be able to see the individual samples, which I covered in the previous episode on digital audio. You can scroll horizontally with the bar at the bottom. Or you can use the Shift key and the mouse wheel. And you can move audio clips by dragging them from the title bar. The vertical range can also be adjusted by using Ctrl mouse wheel or Shift mouse wheel here on the vertical axis. But I would recommend always having the original range to be able to detect instances of clipping. You can restore the original range by right-clicking here and selecting Zoom Reset. A useful way to make or adjust a selection is with Shift-click. These icons are for the behavior of the mouse buttons, where we have Selection, Envelope, Draw, Zoom, and Multitool. Personally, I find it more useful to leave it on Selection and zoom in with the mouse wheel, so I won't explain these tools. These are the recording and playback monitors. Notice that the numbers are negative and the maximum is 0, which means it's displaying decibels full scale, which I explained in episode 2. The playback level allows you to see sound levels so low that you cannot see them on the waveform. Now, let's explore the functions. Here, you can adjust the recording and playback levels, either by dragging or by double-clicking to enter a number. By the way, you can rearrange the sections by dragging them from this bar. Here, you can select the input device. That is, here you have to find and select the microphone with which you want to record. Here, you can select the output device, so the speakers or headphones through which you want the sound to be played. This project rate down here is the sample rate you are using in your project. Here you have these time displays, which by default show the start and end time of your selection. But personally, I prefer it to show the start time and length. And if you want to switch between displaying milliseconds or number of samples after seconds, you can select it here. To play a selection in a loop, select the desired area and press L. This gray bar will indicate the loop region. You can then use the L key again to turn loop on and off. And with Shift L, you can define a new region or simply remove the loop region. If you have a selection, but when playing back it goes outside of this selection, you may need to turn loop off. Now, I will talk a bit about editing tools. Using the icons is not efficient, so I will just mention the shortcuts. The shortcuts to copy, cut, paste, undo, redo, and select all are the typical ones used in all software. You can also delete audio with the delete key. But be careful when deleting, because you can generate a discontinuity which will sound like a click. To avoid that, you can use the Z shortcut to find a nearby zero crossing. In this way, you will start selecting from a point very close to zero. So, if you delete audio with both ends of the selection on a zero crossing, you will avoid discontinuities, and you will not hear a click. On a mono track, that is, with a single channel, it is usually enough to press Z once. But on a stereo track, that is, with two channels, sometimes you have to press Z several times until it stabilizes at a zero crossing. If you press Z with a selection, Audacity will find zero crossings at both ends. In these examples, I'm zooming in so you can see the zero crossings, but the Z shortcut is useful for finding zero crossings even when zoomed out. If the cursor is on a peak, you will also hear a click when you start playing, which can be annoying. You can avoid this by moving the cursor to a zero crossing. Or, if you have a point that's silent or with a very low level, you can also place the cursor there. In this example, I will compare the cases with the cursor at a peak and at a zero crossing. Listen carefully at the beginning of each example, and you will notice the click in the first case. The same thing can happen at the end of a selection. With the Ctrl-I shortcut, you can split the audio clip. This is useful for moving or rearranging audio clips. You can rejoin two adjacent clips by clicking on the split point. Splits are also useful for erasing long portions without discontinuities. You can mark the zero crossings with splits, and that way you don't lose it. Then, you can easily select the portion to be deleted by double-clicking. Another way to trim clips is to drag them from this upper part of the clip outline. Although I don't really recommend it due to the risk of discontinuities. You can convert a selection to silence with Ctrl-L. But again, I check for zero crossings after selecting and before silencing to avoid discontinuities. You can create a new track by going to Tracks, Add New. If you want to add an audio to the same project on another track, you can go to File, Import, Audio. Or you can also drag a file from the folder. On the left side, you have the Mute and Solo buttons. Mute allows you to temporarily turn off that track, while Solo mutes all other tracks, leaving only this track on. Here, you can adjust the level of the entire track in decibels, which is called the gain. You can move this slider or double-click and enter a number. Just be careful when increasing the gain, as you can exceed the digital range and cause clipping, which will sound distorted and possibly too loud. In episode 2, I talked about clipping and the use of decibels in digital audio. If you haven't watched it, I highly recommend you to do it for a more complete understanding of manipulating audio. I leave the link in the description. Meanwhile, it is worth remembering that 6 decibels doubles the amplitude, but 10 decibels doubles the loudness, that is, the sensation of volume. Likewise, -6 decibels halves the amplitude, and -10 decibels halves the loudness. Here, you can change the pan, that is, the balance between the left and right channel. Different tracks can have different sample rates. In fact, this is a good way to find the sample rate of an audio file. Just keep in mind that whenever you listen to the project and when you export your final audio, the project sample rate is the rate that will be used. Here, we can also see a bit depth. However, this bit depth is not the bit depth of the audio file, but rather it is a bit depth used internally in Audacity. To find the bit depth of a WAV file, you can first find the bitrate in the file properties, and then divide the bitrate by the sample rate. Keep in mind that if the audio is in stereo, this bitrate will be that of the two channels added together. This way of finding the bit depth is specifically for WAV files, since MP3 files store information in a different way than PCM and can have a variable bitrate. Now, let's record some audio. But before recording, you typically have to check two things. The first is that the correct microphone is selected. If it doesn't appear, you probably connected it after opening Audacity. In that case, you will need to close and reopen Audacity, as the software only detects devices on startup. The second is that the recording level should be at a modest level. If the recording level is at the maximum, clipping is very likely to occur. And if it is very low and we amplify it later, the recording can turn out noisy. Remember that when this red light on the monitor turns on, it means that clipping has occurred. If you click where it says "Click to start monitoring," you will be able to see the microphone levels before you start recording. The blue bar marks the maximum detected, and I would recommend that it reaches between -12 and -6 decibels while you're talking. Now, to start recording, we can click on this button or use the R shortcut, and you can stop the recording with the spacebar. Hello, 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 hello. This is a test. If necessary, readjust the recording level and start your recording again. Now, let's explain effects. The list is huge, and although I recommend you to experiment with all of them, I will only mention a few of the most useful ones. One of them is Amplify. You simply select a portion of audio, then go to the Effects menu, select Amplify, and enter by how many decibels you want to amplify the wave. The first number that comes up automatically is the maximum amplification possible before clipping. You can also attenuate the wave by entering negative decibels. Normalization is similar to amplification. But here, you enter the maximum peak amplitude you want, instead of the amplification factor. So, normalizing to -6 decibels amplifies or attenuates the wave so that the maximum peak amplitude reaches -6 decibels full scale, which corresponds to an amplitude of 0.5 in linear scale. We can also fade in and fade out. We have several effects that, even though they are not very useful for editing, they are still fun. Two of them are echo and reverb. The difference between these two terms is that echo is when we can distinguish individual repetitions. What's up? This is Mario, and welcome to Awesome Acoustics. While reverb is when we perceive a continuous extension of the sound. What's up? This is Mario, and welcome to Awesome Acoustics. For the echo, we have two parameters. The delay is the time between each repetition, and the decay factor is by how much the amplitude is multiplied on each repetition. This would be a number between 0 and 1, and the lower the number, the greater the attenuation on each repetition. You can use this preview button to try different settings before applying the effect. What's up? This is Mario, and welcome to Awesome Acoustics. What's up? This is Mario, and welcome to Awesome Acoustics. What's up? This is Mario. The reverb effect has a lot of parameters, and at the moment they are somewhat complicated to explain. Here, I simply recommend experimenting with the parameters and hearing how each one affects. Another fun effect is the reverse effect. What's up? This is Mario, and welcome to Awesome Acoustics. Change pitch, speed, and tempo can be a bit confusing at first. Change speed compresses or expands the audio in time, but this also changes the periods, and therefore the pitch. You can enter the speed change with a multiplication factor or an addition or subtraction of percentage.
What's up? This is Mario, and welcome to Awesome Acoustics.
What's up? This is Mario, and welcome to Awesome Acoustics.
To change the speed of the audio without affecting the pitch, you can use change tempo. What's up? This is Mario, and welcome to Awesome Acoustics. What's up? This is Mario, and welcome to Awesome Acoustics. And to change the pitch without affecting the speed, you can use change pitch.
What's up? This is Mario, and welcome to Awesome Acoustics.
What's up? This is Mario, and welcome to Awesome Acoustics.
If you need to apply the same effect many times, you can repeat the last effect you used with the Ctrl-R shortcut. To generate a waveform with a specific frequency and amplitude, we can go to Generate, Tone. Here we can select the waveform, frequency, amplitude, and duration. The amplitude is on a linear scale, so the range goes from 0 to 1. Here, you have to be very careful with the amplitudes, in order not to generate waves that are too loud and could hurt your ears. In your first attempts, I would recommend that you do not exceed an amplitude of 0.5 for a sine wave, and that you do not exceed an amplitude of 0.1 for the rest. This is because different waveforms can have different loudness even when they have the same amplitude. This is related to frequency content, which I will explain in the next episode on spectral analysis. You can also generate noise by going to Generate, then to Noise. Here, I recommend that you do not exceed an amplitude of 0.3. There are many other useful features in Audacity that I haven't mentioned, but we will discover them in future episodes as we learn the theory behind them. Once you have experimented with the software and found the features that you're most interested in, you can create custom shortcuts in Edit, Preferences, Keyboard. For example, if you use the amplify effect a lot, you can assign a shortcut to it. We first look for the function here and select it. Then we click on this field and mimic the desired shortcut. In this case, I will press Shift-A on the keyboard. Make sure you click on Set. Here we can see that the shortcut is now assigned. You will also see the shortcut in the menu. Let's try using our new shortcut. You can also hide functions you don't use by going to any of these menus. Then, to add remove plugins. You look for the name of an effect that you're not interested in, select it, and press Disable. You can select multiple with Ctrl-click and Shift-click. At any time, you can re-enable functions that you have previously disabled. This is what my effects menu looks like after disabling effects I don't use. In addition to the waveform, there is another way to visualize an audio, which is the spectrogram. To activate this view, you click on the track title and select Spectrogram. This is a way to visualize the frequency components separately. The vertical axis shows the frequencies, and the amplitudes are shown with colors. The color scale of amplitude from lowest to highest goes through the colors black, navy blue, magenta, orange, and white. Here, it can be very useful to adjust the vertical range. To help you interpret the spectrogram, I will show an example with sine tones. Sine waves have only one frequency component, so in this case, each tone only has one line. And remember that frequency is related to pitch. However, any other sound is made up of many frequencies simultaneously. I will also explain this in more detail in the next episode. Personally, the most useful view is the multi-view, which shows the waveform and the spectrogram at the same time. The waveform is more intuitive and allows us to watch out for clipping, but some things are more clearly visible in the spectrogram. For example, some noisy sounds with low amplitude are indistinguishable in the waveform, but they are very obvious in the spectrogram. Also, discontinuities can be identified in the spectrogram as a vertical line. To set multi-view as the default view, you can go to Edit, Preferences, Tracks, Default View Mode. Finally, I want to talk about saving a project and exporting. A project file can be identified with the Audacity icon. A project can contain many tracks and keep things like clip splits. This is the best way to save an audio that you are still working on. Just keep in mind that long projects can take hundreds of megabytes of storage. The project file contains all the data. Exporting is when you mix your entire project down to a final audio, usually in MP3 or WAV format. If you reload this audio into Audacity, this will give you a single audio without the ability to manipulate individual clips. So, as long as there is the slightest chance that you will have to go back and edit your audio, it is most convenient to also keep your project file. When exporting to MP3, here you can select the quality, which will influence the file size. For music, the first option is of good enough quality that the compression is imperceptible. For voice, even the second option should be more than enough. An MP3 of high quality, such as 256 kbps, is typically indistinguishable from a WAV file. Someone who says otherwise is very likely under a placebo effect. Or the MP3 could have one of the following problems. The first is when you take a low-quality MP3 and then re-export it into a new high-quality file. This does not restore the quality of the audio, as the high-quality information was lost beforehand when the low-quality MP3 was created. The same thing would apply when exporting a low-quality MP3 to WAV format. Therefore, it is always good to have a high-quality backup of the audio. The other problem is when an MP3 is re-exported many times in a row. Compression is cumulative, so after a few re-exports, the audio can degrade considerably, even if you started with a high-quality MP3. For this example, pay attention to the symbol at the beginning of each clip. To avoid this, it is best to make new edits on the original audio and export new versions from that audio, instead of reloading the MP3 and adding more compression on each export. If you need to export the file for use in other software, but you still want that audio to be a high-quality backup, the safest option is to export it in WAV format. This format can take up to 2 to 5 times the storage of a good quality MP3. But it is the most faithful digital representation of the original audio, due to the PCM representation. In fact, recordings made directly in Audacity are also represented in PCM, just at a higher resolution than normally used in WAV files. For the final version of your audio, the MP3 format could be suitable, as long as it comes from uncompressed audio and the compression is of high quality. With that, we conclude this episode, and in the next one, we will talk about additive synthesis and spectral analysis. See you!